Hi friends, welcome to follow up. Let's have a look at problem 523, continuous Subarray sum. So in this video, again, we are going to use data structure to help solve the problem. So here we are going to use dictionary or hash map. So this problem is also a prototype problem. So one could actually practice more on this kind of problem and its variants. So in the previous several videos, we demonstrated this point. So now in this video, let's practice again. So here we are given an integer array called nums and an integer key. So we want to return true if nums has a good subarray. Otherwise, we return false. So the definition for a good array is the following. First, the array or the subarray has length at least 2, and also the sum of elements of the subarray is a multiple of key, right? So here are 3 examples. In the first example, we have 2 and 4, right? So their sum to 6, so it's a multiple of 6. So in the second example, if we look at this subarray, actually the whole array. So the size is 5 and the element sum to 42. So 42 is a multiple of 6, right? So we're going to return true. While in example 3, so the return is false. So before we look at the code and the logical analysis, let's look at the constraints. First, the length of this nums list can be as long as 10 to the power 5. So in other words, we need to think of term complexity, right? So secondly, the elements in the list are non-empty, right? And the sum of all the elements is bounded above by 2 to the power 31 minus 1. So this number is nothing but the largest possible 32-bit integer unsigned. So this k is also in this range, right? But this k is greater than or equal to 1. So with that aside, we are ready to do the analysis. So basically, we are going to use partial sum. But for partial sum and for the dictionary, we are going to store the remainders. Let me first write the code and test that, then we can walk through. So here, this problem requires that we find if such a good array exists or not, right? Not for counting. So we are going to initialize a result variable. Let's call it false at the very beginning. And then if we find one, we are going to flip the flag and do the return. Otherwise, we directly return the result status. So the dictionary will be something like this. So we're going to store the partial sum modulo the key, right? So partial sum and the index. So the index is the first appear index, right? So here the partial sum in the sense of modulo this key, right? So we can always do the modulo operation because this k is greater is non-negative. It's actually strictly positive. We'll see. Yeah. So current. Let's initialize a current variable. So this current will carry the partial sum up to index. So let's see I. So in this problem, the index will come into play explicitly due to the requirement that the length of the array will be at least 2. So here, let me make a correction. So we are going to use this partial sum starting from -1. So because we have nothing, so this is the earliest index, right? Just for counting length purpose. So with that said, basically we can do the for loop. So we add some information by using enumerate function for iy in enumerate nums. Then at the current index I, so the partial sum will be this, right? Then if you compute the remainder, it will be something like current modulo key, right? So the check condition will be if R in D and I minus dr is greater than or equal to 2. So which means if R in D and then the corresponding earliest index is, let's say, is I0. It means that let's call dr denote it to R0. So basically it says that R0 plus 1 up to the current index, so it's a valid, corresponds to a valid subarray. So we'll come back into this point later. Then if we find such a good array, so we're going to return true, right? So let's do not update, forgot to update. If R not in D, right? It means that this R appears the first time. Then we're going to do this. dr we set to be the current index, right? And if R is already in D, so we do not update the index because we want to check the longest possible subarray. So because the length constraint. So with that said, after this for loop, we are ready to return the result status. So before we make walkthrough or any comments, let's first test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, let me come back here to explain this line again, and then we do a walkthrough. So here, R in D. So let's say we have a partial sum, right? Modular this key, right? So if from start index 0, then up to say I0, so you have a partial sum S1. So modulo this k, it equals the R1, right? So in other words, S1 is a multiple of k plus R1. And then we have another one, let's see, from I0, then continue I0 plus 1 up to index I. As you can imagine, this is the index we are looking at. So if they have a sum S2 and modulo k equals R2, right? In other words, S2 is a multiple of k plus R2, right? Then if R2 equals R1, in other words, the difference of R2 minus R1 is 0. So it means that for the partial sum, it means that for the subarray starting from index I0 up to I, so this corresponding to a sum S2 minus S1. So because S2 is a multiple of k, right? Multiple of k, let's call it L times k plus R2, right? Then minus, so S1 is also a multiple of k. Let's see T, that's just a times k plus R1, right? So then this will be L minus T times k, because R1 and R2 are assumed to be the same. Then this means that for this subarray, so their sum is a multiple of k. This is nothing but the meaning of this line of code. So we check if R is in the dictionary, and then if, so the length of this index is nothing but I minus I0 minus 1, then plus 1. In other words, I minus I0. So the I0 corresponding to the index for R1, right? Then we have R, the same R, we check D, and then we use the current index minus the dr. If this is greater than or equal to 2, it means the corresponding subarray has length at least 2. Then in this case, it means that we have a valid good array. So we are going to return true, right? And you know, this if is very easy to understand. So with that said, we explained the code in a very refined detail. So now let's do a walkthrough. So here we can use example 1. So for example 1, originally the result will be false, right? So the dictionary will be 0, negative 1. And then current will be 0 in the sense of modulo k equals 6. Then if we look at 32, right? So we have current equals 32, and then we examine the remainder. The remainder modulo 6 is 5, so we have r equals 5, but 5 is not in the dictionary, right? So we just need to update the dictionary. So to be 0, -1, and the remainder 5 first appears at index 0, right? And then we look at 2. So if we look at 2, and then the current will be 25. So you can do this computation in the sense of modulo key. In other words, you can set r equals the current equals r, and nothing, it still works. So let's see, we can set this will still work. So, but you know, it just let's do this computations, right? Then we modulo modulo 6, so the r will be 1, but r1 is not in the dictionary. Let's just update dictionary. So we have 5, 0, right? Then for r equals 1, it first appears at index 1, right? And then let's look at 4, right? So for 4, current will be 29. So 29 modulo 6 is 5, right? So 5 is in the dictionary, right? So D5 is nothing but 0, right? So if we compute the length of this array, so it's going to be the current index is 2, right? 2 minus D5, this is 2. So this for sure greater than or equal to 2. And in other words, slotting from index 1, index 2. So this corresponds to a good subarray. So we're going to return true. Yeah, actually the process stops here, right? So this is a full walkthrough for example 1. So now for completeness, we can do a walkthrough for example 3, right? So for example 3, earnestly dictionary will be 0, -1 for the first appeared index. And then we look at I equals 0 as corresponding to the number 23rd. The current is 0, right? And then the current will be 23. And then we compute this modulo 13. We are going to get r equals 10. But 10 does not in the dictionary. So we're going to update this dictionary. So 0 first appears, and then 10 appears at index 0. This one. And then we look at index 1. So for index 1, so the number is 2. So if we compute current, the current is 25. Then modulo 13, we are going to get 12. And 12 is not in the dictionary, so we do the update. So it gets -1, 10 corresponding to 0, and this remainder corresponding to index 1. So now let's continue for index 2. So for index 2, the number is 6. So if we add 6, so we get 31. So 6, so 21, so modulo 13, we're going to get 31 minus 26, we get 5. So r equals 5, right? So 5 is not in the dictionary, right? So we're going to update the dictionary to be, let's copy this original stage above the previous stage, and then plus this one, r equals 5, corresponding to index 2. And then let's look at index 3. So index 3 corresponding to number 4, right? Then current will be 35. And let's compute the r. So the r will be, because we add 4, so you can use this r to compute. This is none. So none is still not in the dictionary. Then we update this dictionary. So the first occurrence index for none will be index 3. So now let's look at the last one that corresponds to 7, right? And the index is 4 and the number is 7. So the current will be 42, right? And then so if we 42, So let's see. We have 7. So we have what's the remainder? So 35 plus 7 is 42. 42 modulo 13, right? So it's going to be 3, right? So, or you can use this one, plus 7, that is 16. 16 minus 13 is also 3. So it means that our computation is correct. Then 3 is still not in the dictionary. So actually for up to now, we can already return true. But let's do an update for this dictionary. So this R is 3. 3 corresponding to index 4, right? So after this for loop, nothing has returned. So we're going to return the original state for the result, that is false, right? So we are going to return false in this case, or return the result state. So that's the walkthrough for example 3. So overall, we give 2 walkthroughs. One is for an example which corresponds to a return true, and the other is an example corresponds to a return false. So with that said, that's the end of explanation for this specific problem. So to sum up, in this video, we explained how to use dictionary to solve this problem. And in between, we are using essentially partial sum, but here we compute partial sum up to a modulo k, right? So with that said, that's about it for this video. Thank you.